particle moving in an inclined plane. Now, an object of mass m slides on a frictionless surface inclined at an angle theta. Okay, this is a frictionless surface. An object is sliding in this frictionless surface. This is inclined with an angle theta. Now the forces acting on this mass will give you two things. One is the acceleration of the object and another one is the speed of the object when it reaches the bottom. Now there are two forces acting on the object. One is the downward gravitational force. So the downward gravitational force will act like this. So this is your downward gravitational force. And another one is the normal force. So this will be acting like this. So the forces acting on the object are downward gravitational force mg and the normal force which is perpendicular to that of the inclined plane. Now we have to draw the free body diagram. So to draw the free body diagram, we have to assume the block of mass m as a point mass. So I am assuming the block m as a point mass. So this is the point mass m. Now there are two forces acting on it. So we have to draw the forces in the free body diagram. One is the downward force, that is mg. And another one is a normal force which is perpendicular to that of the inclined plane. So it is like this. So this is your free body diagram. So we have drawn a free body diagram to represent the mass and the forces. Since the motion is on the inclined plane, see the motion of the object is in the inclined plane, we have to choose the coordinate system parallel to the inclined surface. So we are going to choose the coordinate surface here as this as the x-axis and this as your y-axis. Okay, so this is how we are going to choose the coordinate system which is parallel to that of the inclined plane. Okay, now I am going to resolve this mg into two components. One is the parallel component and another one is the perpendicular component. Okay, so the parallel component and perpendicular component. Now this is your perpendicular component. The perpendicular component is given by mg cos theta. And this is the parallel component. This is given by mg sin theta. Okay. So we have taken two components. One is the parallel component and perpendicular component. Parallel component is mg cos theta and parallel component is mg sin theta and perpendicular component is mg cos theta. Now the angle made by the downward gravitational force with that of the perpendicular component is theta. Okay, so the angle made by the gravitational force with the perpendicular to the surface is equal to the angle. This angle is nothing but equal to that of the angle of inclination. The angle made by the perpendicular component with that of the gravitational force is equal to that of the angle of inclination theta. So we have to prove now this angle is equal to this angle. Now this is your angle of inclination theta. Now this is your perpendicular component and this is your parallel component and this is the downward force mg. This downward force mg I am extending up to this one. Okay. Now this angle I am going to take it as theta 2 and this angle I am going to take it as theta 1. Okay. Now this is 90 degree. This is what? 90 degree. I am marking this as what? C. Okay. The previous diagram I have taken like this. Now I have to prove this angle is equal to what? This angle. This is your angle of inclination theta. In this diagram I have taken this as what? Theta 2. I have to prove theta 2 is equal to what? Theta. Okay. Now I am going to take the triangle. In triangle ABC. Okay. Total angle. What is the total angle in the triangle? That is 90 plus theta 1. So the total angle in a triangle is 180 degree. So I can write 90 plus theta 1 is equal to 180 degree. Okay. So we can write theta 1 as 180 minus 90 minus theta. So what I'll get it here, it is 90 minus theta. So theta 1 is equal to 90 minus theta. Now if you take these two this angle is how much? 90 degree. Okay. So I can write angle EAD is equal to theta 1 plus theta 2, which is equal to what? 90 degree. Which is equal to what? 90 degree. Okay. Now I am going to substitute here. I am going to write this for theta 2. So theta 2 is equal to 90 minus theta 1. 90 minus what? Theta 1. Now what is theta 1? Theta 1 is theta minus 90. So theta 2 is equal to 90 minus theta. So what is 90 minus 90 is 0. Plus and plus. So theta 2 is equal to what? Theta. So now we have proved that theta 2 is equal to theta. That is, the angle of inclination is equal to the angle between the perpendicular component and the gravitational force. Now when I take this disk diagram, the object is moving only in the x direction. There is no motion in the y direction. The object is moving only in the x direction. There is no motion along the y axis. So now I am going to apply Newton's second law to y direction. Newton's second law to y direction. So what is the net force here? Force F is equal to m into a. What is Newton's second law? F is equal to m into a. So according to Newton's second law, F vector is equal to m into a vector. Okay. Now there is no motion along what? Y axis. Okay. So what is the net force? Here what is the net force? The net force is mg cos theta, which is along the minus j axis, and n, which is along the positive vector j axis. So I can write mg cos theta minus j plus nj. Okay. So the force I am going to write it as mg cos theta minus j vector plus nj vector, which is equal to mass m. Acceleration is what? 0, because there is no motion along the y-axis. So I can put as what? F is equal to ma. A is 0, so this term is 0. Okay. Now comparing the components, this can be written as what? nj vector is equal to mg cos theta into j vector. Okay. Now comparing components of j vector, what I'll get? N is equal to mg cos theta. N is equal to what? Mg cos theta. So the normal force exerted is equal to that of the mg cos theta. So the normal force and mg cos theta are same. Okay. Now taking the x-axis, the object is having motion in the x-axis. Okay. So the object slide along the x direction. Now we are going to apply the Newton's second law. Now here only in the positive x-axis the object is sliding. There is no force in the negative x-axis. There is no force in the negative x-axis. So what is the net force? Net force is mg sin theta I vector. Net force is what? Mg sin theta I vector. The acceleration is not 0. Acceleration is also along the I vector. Acceleration is also along the I vector because it is along the positive x-axis. So we can write now applying Newton's second law. F vector is equal to m a vector. What is your F vector here? mg sin theta into I vector, which is equal to m a I vector. Okay, there is only one force is acting along the x direction. Here acceleration is also along the x direction. Okay. Now comparing the components. So what will you get? mg sin theta. Both the sides we have only I component. So mg sin theta is equal to ma. M and m will get what? Cancel. So a is equal to g sin theta. This gives the acceleration of the object. Okay, this gives what? The acceleration of the object. So the acceleration is depending upon the angle of inclination theta. The acceleration is depending upon what? The angle of inclination of theta. Now we have to find out the speed of the object when it reaches the bottom. So speed of the object when it reaches the bottom. So how to find out the speed of the object? How to find out the speed of the object? That is v square is equal to u square plus 2as. V square is equal to what? U square plus what? 2as. We have to use this formula. Okay, the speed is along the x direction only. Okay, we know a is equal to, what is the initial speed? The initial speed is equal to 0. Initial velocity is equal to 0. So v square is equal to 2, and your a is what? G sine theta. So what will you get? G sine theta into s. So what I can write? V is equal to root of 2gs sine theta. 2gs what? Sine theta. This is the speed of the object when it reaches the bottom. So we have found out two things. One is the acceleration of the object, and another thing is what? The speed of the object when it reaches the bottom.